New genetic contributions from Neanderthals are being appreciated thanks to studies delving into Neanderthal and human genomes. Already, it was understood that Neanderthal genes contributed to the disease phenotypes of modern humans. But now it is emerging that Neanderthal genes bring quite a bit more to the genomic party. A recent study that scoured human genomes for Neanderthal alleles suggests that our Neanderthal inheritance has contributed to non-disaccerated characteristics such as skin tone, hair color, sleep patterns, mood, and even a person's smoking status. Another study, this one focused on Neanderthal remains of unusually high quality, identifies a wealth of new gene variants that are influential in modern humans, including variants related to plasma levels of low-density lipoprotein cholesterol (LDL-C) and vitamin D, eating disorders, visceral fat accumulation, rheumatoid arthritis, schizophrenia, and responses to antipsychotic drugs. The first study comes from researchers based at the Max Planck Institute for Evolutionary Anthropology. These researchers, led by Janet Kelso, Ph.D., published their findings October 5 in the American Journal of Human Genetics in an article entitled "The Contribution of Neanderthals to Phenotypic Variation in Modern Humans." The article describes how the Max Planck researchers used baseline phenotypes collected for 112,000 individuals by the UK Biobank to elaborate on previous findings that identified associations between signatures of positive selection on Neanderthal DNA and various modern human traits. Whereas previous studies in this vein focused on disease risk, the American Journal of Human Genetics report focused on specific phenotypic consequences. Here, we show that Neanderthal DNA affects skin tone and hair color, height, sleeping patterns, mood, and smoking status in present-day Europeans, the article's authors wrote. Interestingly, multiple Neanderthal alleles at different loci contribute to skin and hair color in present-day Europeans, and these Neanderthal alleles contribute to both lighter and darker skin tones and hair color, suggesting that Neanderthals themselves were most likely variable in these traits. The second study comes another team of scientists based at the Max Planck Institute. These scientists, led by Kate Proofer, analyzed billions of DNA fragments sampled from a new individual in the Croatian cave, dubbed Vindiga 33.19, a female who lived roughly 52,000 years ago. Upon analysis, this Neanderthal genome revealed many long-buried secrets. For example, one finding is that early modern human gene flow into Neanderthal populations occurred between 130,000 and 145,000 years ago, before the Croatian and Siberian Neanderthals diverged. Also, it appears that modern non-African populations carry between 1.8% to 2.6% Neanderthal DNA, which is higher than previous estimates of 1.5% to 2.1%. Detailed results appeared October 5 in Science, in an article entitled "The High-Coverage Neanderthal Genome from Vindiga Cave in Croatia." She carried 1.6 differences per 10,000 base pairs between the two copies of her genome, fewer than present-day humans, suggesting that Neanderthal populations were of small size, the article's authors wrote. Our analyses indicate that she was more closely related to the Neanderthals that mixed with the ancestors of present-day humans living outside of sub-Saharan Africa than the previously sequenced Neanderthal from Siberia, allowing 10–20% more Neanderthal DNA to be identified in present-day humans. Lastly, the scientists identify a wealth of new gene variants in the Neanderthal genome that are influential in modern-day humans, including variants related to plasma levels of LDL-C and vitamin D, eating disorders, visceral fat accumulation, rheumatoid arthritis, schizophrenia, and responses to antipsychotic drugs.